small cross-section design to withstand instantaneous piston wind as fast as 30 to 40 meters per second. Fully aware of the limited time for installation and construction on existing urban rail lines, Huawei offers trackside all-in-one devices that are easy to install. This makes it possible to quickly deploy one side within 30 minutes, increasing installation efficiency by over 60%. When a train enters the depot, the on-train AP switches to the client mode within 1 minute and connects to the AP in the depot. Radio calibration is also triggered to effectively prevent code-channel interference, ensuring stable link transmission. A rate of up to 1.2 gigabit per second per radio ensures that at least 240 gigabit data generated during the train running every day can be automatically dumped within 30 minutes. The train automatically enters the power-off state within 1 hour and automatically wakes up the next day. After the train stops, videos of inspection personnel are backhauled in real time. Remote consulting facilitates maintenance, improving inspection efficiency by over 30%. Real-time insight into inspection personnel and device locations maximizes security. Huawei Wi-Fi 6 is powering smart urban rail towards fully autonomous driving.
Around every object in this world, connections are forming. What kind of world will tomorrow bring? Unfolding the future, exploring the intelligent world 2030. AI will predict the path of contagious diseases to accurately show how they will spread. AI will enable targeted cancer treatments that minimize damage to healthy cells. Portable devices will make it easier to receive professional medical tests. Technology will make health computable and improve quality of life. Precision farming will build visualized data graphs. Smart vertical farms will create new agricultural models. 3D printing will provide a solution for supplying healthy, sustainable meat. Data-driven food production will enable plentiful, healthy, and green diets. Digital cataloging, off-site storage, and automated delivery will free up space in your home. Intelligent building management will bring your home closer to net zero carbon. Smart homes will be able to adapt and understand what you need. New interactive experiences will give you a personalized living space. Autonomous vehicles will provide a mobile third space. More shared vehicles will mean faster, low-carbon transport. And a smart, green experience will drive you into the future. New digital infrastructure will be the engine of digital cities. Smart government services will give cities a human touch. Intelligent environmental protection will help create more livable cities. New digital infrastructure will make cities more human and livable. Unmanned operations and services will make up for labor shortages. New production models will be personalized and create resilient, intelligent supply chains to help enterprises respond to crises. New productivity will reshape production models and enhance enterprise resilience. Floating power plants will enable renewable electricity generation. The energy internet will make synergies between generation, grids, load, storage, and consumption, making power supplies more efficient and flexible. Intelligent, green energy will make for a better planet. ICT will enable digital trust. Regulations will redefine digital trust. technologies, and regulations will reshape a trusted digital future. Healthcare, food, living spaces, transportation, cities, enterprises, energy, and digital trust. We believe technology is forging a brighter future.
The intelligent world is within reach. Maintaining steady growth amid new situations, Huawei EBG provides innovative solutions and is creating a digital ecosystem where all players create and share value together. Huawei works with global partners to continuously promote industry digitalization and help customers go digital. We enable synergy between cloud, AI, and connectivity to provide public cloud services and hybrid cloud solutions that deliver high stability, reliability, security, trustworthiness, and sustainability. Through joint efforts, we have implemented city intelligent twins, provided overall upgrade solutions for financial institutions, developed the comprehensive transportation solution by adhering to the concept of convenient travel and smooth logistics, embraced the transformation of the global energy industry, and are striving to help achieve carbon neutrality, and have helped the manufacturing industry to go digital and intelligent. Huawei is committed to cultivating innovative talent in higher and vocational education and driving equity in basic education. We have teamed up with partners to accelerate digital transformation of the global healthcare industry and helped internet companies address the challenges brought by the surge of network traffic and demands for computing power. Our Intelligent Campus solution was developed by integrating new ICT technologies, helping campuses achieve all scenario intelligence. We have built data centers to intelligently upgrade all industries. Huawei implements fair, transparent, and simple policies to benefit our partners and to promote collaboration and sharing. We provide consistent, high-quality services worldwide, improving O&M efficiency and system availability. Pivoting toward industrial digital transformation opportunities, Huawei EBG will work with our customers and partners to build an open ecosystem based on the Intelligent Twins architecture, accelerating digital transformation across all industries and creating new value together.
The history of human civilization is tightly interwoven with progressing connectivity. From not records to written languages, from signals in enclosed turrets to win-win free trade, from post riders to instant communication. We never stop pursuing and redefining connectivity. Taking each step firmly, we extended connectivity into new, untouched areas beyond the known world. What wonders can we see in connectivity today? Communicate with street lamps, interact with vegetables, resurrect dinosaurs, and see them up close. Find a way out before despair. In the era when everything is connected, technology brings such imaginations to life. Data communications networks with a super capacity create order out of torrents of data. Data communications networks with intelligent experience replace best effort with SLA guaranteed forwarding. Data communications networks with autonomous driving, replace manual intervention on late-night shifts with network autonomy and self-healing. Today, data communications networks, bursting with intelligence, harness the power of the 4 engines. Connect people, connect enterprises, connect computing power. Laying a digital foundation for new infrastructure. Enabling a digital bridge for all industries. Working behind the scenes, intelligent IP networks ensure shopping is more personalized than ever. Every financial transaction is smoothly made. Valentine's gifts are swiftly delivered via robots. Each question has more and richer answers. Every life receives the respect it deserves. And a new journey can be embarked on fearlessly. Connectivity will never cease to evolve, because no matter where we are, we must connect with our loved ones. And to the road we must take. Connecting value. Connecting hope. Connectivity is limitless. Connectivity knows no bounds.
Good afternoon, ladies and gentlemen. Now you have a face behind the voice. Thank you very much, and welcome to the beautiful city of Bangkok. We had a little bit of a trouble to set up. We had to synchronize our people who are actually watching us from far abroad. So we are not alone here in the room. There will be many other people following us on the video stream. That was the reason we had to delay a little bit the start. Sorry for this, but now we are here. So, my name is Norman Frisch. I'm marketing director for Huawei Transportation Group, Enterprise Business Group. I've been in the railway business for so many years, I almost forgot about it. It's almost 30 years now, so it's a long, long, long time. Today, we have some very exciting presentations we want to go through. And a lot of these presenters will be very keen to actually show you what is actually happening in their sector. And for that reason, I want to keep my presentation very short here. So let me introduce first of all to the speakers you will be seeing today. And I need to help a little bit. You know, with coming age, I need these kind of help. I'm still working on paper, so I'm old. I'm working on paper. So the first speaker of our session today will be Mr. Aaron Wang. Mr. Aaron Wang is Senior Vice President of Huawei Asia Pacific Enterprise Group Business Group. Following his presentation, there will be Mr. Jiang Shi, who is the Vice President of the Global Transportation Business for Huawei. He visits us from Shenzhen and very keen actually to see what our organization has actually brought up for the railway and for the smart urban rail communication system. Then we have a person dialing in through a video link. He was not able to see us here in person, but Mr. Li Songhao is the director of the China Association of Metros, CARMET, who will send us and present us through a video link. Following that, there is Mr. Suyavit Apushatapul. I hope I got the name right, as good as I can. Mr. Ashatapul is the superintending engineer of the maintenance center in signaling and telecommunications department of the State Railways of Thailand. So we will see something about how the State Railways of Thailand is actually approaching communications and operations in the new age of telecommunication. And last but not least, there will be Mr. Sang Chao Lee, the Deputy General Manager of Asia Pacific Regional Center of the CRSC International Company. So without further ado, I would like to ask Mr. Aaron Wang to join us here on stage, please.
Okay. Good afternoon, ladies and gentlemen. I would like to take this opportunity to thank and welcome everybody here today for Huawei Global Rail Summit 2022. It's a great pleasure that we are all here today to share the trends of rail sector. 2022 is another year of challenges and opportunities for all industries. We are seeing some progress with countries like Thailand and Singapore gradually open up to the world again. This is a good sign to see the transportation industry recovering from pandemic and its subsequent turbulences. Passenger and freight sector will follow different recovery routes, so it's key for transportation stakeholders and organizations to plan ahead, making sure the transportation network are ready for the return to normal operations. We've seen the global investment in new rail infrastructure and rail industry digitalization are continue to stimulate and recover the economy. Many countries around the world, especially in Europe and Asia Pacific, are planning comprehensive digital transformation for the rail industry. For example, the European Union proposed the Sustainable and Smart Mobility Strategy to put European transport on track for the future. By 2030, freight traffic in the EU is projected to grow by 50%, and passenger traffic on high-speed rail will be double. Smart mobility is a key pillar of your plan. As such, the EU will invest in 5G, AI-driven transportation automation. In the Asia Pacific, it has reached a consensus that new and expansion or reconstruction of robust rail infrastructure together with rail digitalization, including automation, smart operation and maintenance, green energy, and smart IoC shall be continuous and proactive to stimulate to the economy. As a leading global ICT solution provider, Huawei proposed Smart Rail solution with a full service architecture based on diversified connections and unified digital platform to enable real digitalization and business intelligence. For urban rail, Huawei solution serves over 300 urban rail lines in more than 70 cities globally. For example, we support Shenzhen Metro path into digitalization that includes 3 steps. Firstly, reswapping connections by adopting 100G backbone, LTE for Metro, Wi-Fi 6, train-to-ground communication, and even 5G technology. And the second, reconstruct platform by development, urban rail cloud. The third one, service intelligence enablement like smart O&M, smart mobility, smart construction, and smart IOC by leverage of BIM, GIS, video, IoT, AI, big data, and so on. This ensures safe urban rail and high-risk operation efficiency for Shenzhen Metro. Huawei has been supplying into railway as early as 1996 and start supplying wireless train-to-ground communication system globally from 2009. As we all know, the GSMR industry is declining. And with the development of railway digital transformation, the constantly evolving railway requires higher data bandwidth and throughput. UIC, International Union of Railway, has started research on future railway mobile communication system as a successor to GSMR in 2012. Huawei is the first one to complete the test and commercial application of the 5G-oriented and 3G basis FRMCS solution. This will facilitate the smooth upgrade the real mobile communication system and ensure train safety with high bandwidth, low latency, and high reliability. Today, I'm honored to welcome all of you here for our Global Rail Summit in Bangkok. During this event, you also will hear from some of our customer and partner opinions and plan implementation innovative ICT infrastructure on their path to digital transformation. At the same time, we will showcase our innovative ICT infrastructure at the booth and release the FRMCS white paper, all optical smart 300G, industry-leading Wi-Fi 6 train-to-ground communication system, an urban rail cloud platform today, which all together will make up our smart urban rail and smart railway business. Thank you to many customers and partners in the rail industry who cooperate with us on digital transformation. We embrace to your valuable insights and to embarking on this new journey together. Wish you all good health and have a wonderful day ahead. Thank you.
Thank you, Mr. An Wang. It was such a pleasure to have you here and to hear about Huawei's activities in AI, cloud computing, and all these exciting wireless and wireline technologies. Our next speaker now is Mr. Xiangxi. Mr. Xiangxi, would you join me in a minute on stage, please? It's such a pleasure to have you here.
Good afternoon, everyone. I think it's so good to be here, that after a long period of COVID-19 pandemic, to be such a lovely city with own people and nice food. So today, I'm privileged to share some of our solutions and practice in the digital transformation in the rail industry. So this is the best part I love about the rail industry, that we bring people together. And today, we are going to exchange some ideas, then we can create some values together. So let's take a look at the human history. That throughout the human history, we are moving from the agricultural economy to the industrial economy, to the digital economy, with several rounds of industrial revolution, which was accompanied by the great changes happened in the information field and also the energy field. Nowadays, that everybody can say the 5G, the AI, the IoT, the cloud has been widely used in different verticals, including rail industry. And also the energy field, great changes have taken place. More and more green energies are used in rail industry, such as metro trains equipped with battery can be charged when stopped at each metro stations. And also hydrogen-powered trains are in plan. So more green powers will be used, and the public transportation rail industry will, of course, reduce the CO2 emission. And also with more and more intelligent and smart services involved in this rail industry, of course, we can improve the transportation resources and the energy usage a lot in this industry. So all the verticals are going digital. The first wave will happen in the information-intensive industries, such as ICT industry and also the finance. So naturally, their services are digital. So it's easier for them to use more and more digital technologies. And the second wave has been seen in 10 different industries, including the rail industry. Actually, the rail industry is at a turning point of digital transformation. Now, more and more structured and unstructured data require more digital technologies to improve our operation and maintenance for the rail industry. And the third wave will happen in some other industries, such as agriculture. So for the rail digitalization, we can see it through different stages. First, we can see it's like for the metropolitan area, for the metro lines, it's a line operation. So when we build a new metro lines, we build the OCC to manage that metro lines. And we build the PIS, the PA, the SCADA, the signaling with siloed system with their own ICT infrastructures. So the ICT resources usage is not so efficient because ICT infrastructure belongs to different siloed system. Then we are thinking about to move ahead for the second stage, which we call it the network operation. So we are going to build a centralized network OCC, could manage at the beginning several metro lines. Then eventually, we hope it can manage all the metro lines in the city. So all the ICT infrastructure, like networking, storage, security, all these resources will be a cloud platform, can be on-demand allocation to different systems. And also, this service, we can either fast to build a digital platform, which will make the intelligent service easier to deploy and quicker to implement. And the third service, we'll see that smart operation. As I just mentioned, that our connectivity, our platform will enable the upper level application smarter than ever to improve our efficiency for the operation, for the maintenance, even at the construction stage. So throughout the whole life cycle of the metro line operation, we'll introduce more and more smarter services. So the first one we'll say it's smart mobility. So all the public transportation, including metro, bus, taxis, and also the transportation between cities, like high-speed lines, air flight. We bring all these different kind of transportation mode together. So when passengers want to go from A to B, we'll have the smooth way to let him to combine different transportation mode to make this journey smoothly and passenger-friendly. So we can see this different stages of digital transformation of the rail industry. Something is already happening in different countries and doing some pilot project already. So this is the whole structure that we're planning, that we can see from the connectivity, wired and wireless everywhere for the traditional services and also for the new smart services. And for the digital platform, we are going to have the cloud-based ICT infrastructure, which can be on demand or located for different services. More than that we can bring the capability together on a platform, such as video, such as GIS, such as communication, such as big data. So all this capability, we put it in a unified platform, which make much easier for the new services to be used. So we can see then there's three key drivers here. First, we enabled intelligence by building this digital platform. And this digital platform, they will have the ICT infrastructure as the cloud-based platform and also have the capabilities as a platform. It will have the data sharing between different systems, so it can improve collaboration between systems as well. And then we reshape the connection by introducing more new technologies. We are going to officially launch today, like Smart 3G, Wi-Fi 6, 5G-oriented FRMCS. So let's talk about the service first, because today we are going to discuss the real industry and then digital transformation. So building intelligence that we can see, this is a through life cycle practice, not only in one stage, but through the whole life cycle. So first, when we build a metro line or railway new lines, we can introduce some like a smart construction. We use video, BIM, even when the design phase, we can introduce this BIM technology, so which can make the future operation and maintenance much easier. And also artificial intelligence. For example, when we build the metro line, there are some dangerous areas. We need to send some people to do the mail check. But you cannot send people 24/7 on some dangerous spot. And all the report will be done in 1 or 2 weeks. So we can put CCTV camera on some important spot, and with edge computing technology, or even the AI on the cloud. So we can put camera on the spot and the AI on the cloud. So we can do some, intelligent analysis for some potential risk or danger, like someone is not wearing the security helmet, or someone is smoking in the area who is not supposed to do so, or there's a fire or smoke. We can do this with the CCTV, with the artificial intelligence to do so. So we have some practice in Shenzhen, and also we are trying to do this in Singapore as well. So that is for smart construction. Then we talk about the smart operations. The idea is, as I said, that we build a digital platform which brings the data together and improve the collaboration between different systems. So we can see that the passenger flow is an important factor for our daily operation. So we can get this passenger flow information from the ticketing system, from the CCTV do the people counting, even some IoT sensors. We get all this information of the passenger flow. So once we have the information of the passenger flow, it will help us to improve the train operation scheduling. In the peak hour, in the no hour, or weekdays, weekdays, how we can optimize our train scheduling to meet people's travel requirement better. And also, if you have this passenger flow information, it can also help you with the maintenance, because supposedly, if one metro line, they use more passengers in that metro line, the usage of this line will be more. So probably we should have a more frequent maintenance check on those lines who have more people than other lines. So you can see we bring data from different systems, we create some synergy. It can help us to improve the daily operation. And also, while we have this innovative railway parameter intrusion detection technologies. Previously, we used radar-based technology or the camera-based technology. But now we did some project with China Railway Guangzhou. So we use mini-wave radar and the video CCTV camera together. So the radar can check to detect if anyone is walking over the shoulder or cross track. Then the video camera will do the recheck. So we can prevent some, missing alarm and reduce a lot the false alarm because, one technology, it's not 100% correct, but we bring two technologies detection together. It will improve a lot the accuracy of the intrusion detection. So we can also use this to improve the daily operation safer. So I think it's also something that we can target for the smart operation. And also for the maintenance side that you can see we use more 5G, video, AI, even big data. We bring this technology together. That for the driver, that some danger behavior we can detect with the onboard CCTV camera and with the 5G involved. So the onboard CCTV, some trackside IoT will also be transmitted in real time to the OCC. We have several cases that in China for this smart maintenance. Because previously, for example, the Shenzhen Metro, they have a big maintenance team. So it took 2 people 45 minutes to do the manual check of the metro trains with some repairs. So we have this idea that we can have 360-degree picture or image of this metro train with some AI technology. So with this technology, 60% of the check items will be replaced automatically. So we save a lot of neighbors. Nowadays, for one metro trains, we can do it 2 people within 10 minutes. So you can see how much we improve the efficiency of the smart operation. Also for the TFDS, for the freight cars, in Beijing or Zhengzhou, they have a very big team to check the image and compare it if there are any potential for the mechanical part of the brakes, of some important component of the rolling stock. Previously, it's checked manually. Now with CCTV plus AI, then we can do it like 2,000 people. So we save a lot labor and improve the efficiency for the operation level. So that's the first point I would like to emphasize here, that our technologies enable the intelligence for the construction period, operation period, even the maintenance period. That's about the service. Then we need to talk about what the platform which can carry all these different kind of services. So as I said earlier, that previously it's siloed IT system. Now we have this cloud-based platform which can at the beginning manage 1 or several lines. In the future, it can manage all the metro lines in the centralized OCC. So in that center, more smarter services can be deployed much quicker. Because we have the shared ICT infrastructure, we also have the shared capabilities for the AI, for the IoT, for the big data, for the video. Because these capabilities can be the microservice. So when you launch a new service, you can put different components of the system or capability together. Like some emergency response, you can have the camera identify something happened there, then you can use the capability from the ICP platform to send videos or calls to different people, different terminals. So we can make a smarter service deployed much quicker than before. Then we talk about the connectivity. So as I said, we have more new services. We have reconstruct digital plan. Then we need everywhere connectivity, wired or wireless to support that. So today, I'm honored to launch and officially we have 3 technologies. For the OTN, the optic transport network, we're going to have smart 300G. So previously it could be 100G, but we figure out that new service is there and more services is not between stations, but from the stations to a centralized OCC. So more that kind of service don't need too much, electronic level processing. So we can use no latency, bigger bandwidths, better quality of experience to support these new services and the OTN technology. Also for the wireless technology, we're going to use the Wi-Fi 6 to replace the traditional Wi-Fi, which can also provide better performance for the train-to-ground communications. For the mainline, previously GSMA is used, but now it's coming to the end of the life cycle. So the 5G-oriented FRMCS is on the way. And based in France, and also we have regular contact with USA, we are joining the standard meetings there. So also the LTE, as Mr. Wang also mentioned, in China Metro that we use a lot, the LTE for Metro to carry CBTC, also the PIS, CCTV, and so on. So the first technology we are officially launched is the Wi-Fi 6 train-to-ground communication. So previously, you can see that the metro trains, metro industry, they have some pinpoints for the no bandwidth, because, you know, as I said, more and more cameras are used here. Then for one line, maybe at one station, hundreds of cameras will be used. For the whole metro line, could be thousands of cameras, even if the standard or high definition. So the bandwidth we need is much more than before. So the traditional Wi-Fi cannot meet that requirement. And also, the traditional Wi-Fi, when we switch from one IP to another, the handover latency is big, like more than 100 milliseconds. So definitely there is some loss of packet which will influence our image or video. So, and also to apply this AP along the track or at the station is difficult. So we are planning something new, easy to deploy and easy to maintain. So as you can see, the Wi-Fi 6, to tackle all those pain points, we can see we have much faster handover, which is less than 30 milliseconds, so no packet loss. And also the bandwidth, we can support even bigger than 1.4 giga and 160 kilometers per hour. So it's a very good performance to support the CCTV, the IoT sensors equipped in the train or on the track side. And also, we have something new that previously it's difficult to deploy this AP. Now we have this all-in-one trackside AP, which is easier to deploy, save a lot of time to deploy, to install this. Here is the video to showcase that we have a commercial application in Shenzhen Metro Line 20. It's a fully automatic driverless system.
No urban rail, no cities. While urban rail makes city travel faster. Today, autonomous driving trains reaching speeds of up to 120 km per hour become the standard configuration. TCMS, CCTV, and PIS data are backhauled in real time. Train-to-ground Wi-Fi 6 empowers full-time, full-service support. The MBB roaming latency is less than 30 milliseconds, ensuring smooth video backhaul. 500 megabit per second or higher bandwidth is critical to autonomous driving of trains. Huawei offers train-to-ground Wi-Fi 6, enabling up to 1 gigabit per second bandwidth for trains running at 120 kilometers per hour. Multi-link backup, ping-pong handover prevention, link status exception detection, train direction awareness. Trackside APs work in dual 5G mode, allowing each AP to offer bidirectional signal coverage. Trackside 30-degree directional antennas are purpose-built to ensure better directional coverage and stronger anti-interference. These antennas also adopt a small cross-section design to withstand instantaneous piston wind as fast as 30 to 40 meters per second. Fully aware of the limited time for installation and construction on existing urban rail lines, Huawei offers trackside all-in-one devices that are easy to install. This makes it possible to quickly deploy one side within 30 minutes, increasing installation efficiency by over 60%. When a train enters the depot, the on-train AP switches to the client mode within 1 minute and connects to the AP in the depot. Radio calibration is also triggered to effectively prevent code-channel interference, ensuring stable link transmission. A rate of up to 1.2 gigabit per second per radio ensures that at least 240 gigabit data generated during the train running every day can be automatically dumped within 30 minutes. The train automatically enters the power-off state within 1 hour and automatically wakes up the next day. After the train stops, videos of inspection personnel are backhauled in real time. Remote consulting facilitates maintenance, improving inspection efficiency by over 30%. Real-time insight into inspection personnel and device locations maximizes security. Huawei Wi-Fi 6 is powering smart urban rail towards fully autonomous driving.
Very impressive that you can see much bigger bandwidths, lower latency, either to deploy, either to maintain. So that's the Wi-Fi 6. Secondly, I'm going to officially launch this Smart 300G, our new technology for the OTN network for the metropolitan areas. As I said earlier, that nowadays more and more cameras, IoT sensors, even the onboard sensors equipped there, we can get some real-time that the status of mechanical brakes or the temperature, weather information on board, also the trackside to back to the OCC. So more and more services needs more bandwidth for this case. And also the fully automatic operation needs more security from the optic transport network, that we can do some physical isolation and to the user side level, also and the wavelength level. Also for the station operations, then to the transit-oriented development, which need some new services put into commercial use very quickly. So maybe someday there's a big shopping mall, data center, need a lot of services then. And then metro train station, we already have our OT equipment there. You just simply add several interface boards with the current already existed a pair of fiber, you just add several boards in that station. Then you can have these new services with bigger bandwidth, maybe 10G, maybe 20G, to be used. So this is a very good technology for the metropolitan areas as more smarter services are introduced. So we need connectivity to support that. So one fiber, two planes. One is a gray color with a traditional 100 giga services. The other is the colored interface that for each site we can provide 2 lambda. Each lambda can be 10 giga. So suppose we have 10 metro stations for the whole network, we can have like 300 giga. So it's quite a big bandwidth to support the new services. Another thing I want to emphasize here is that the services between different stations are not so big. More services are between stations to the centralized OCC. So with this technology, our cornered interface, they will just pass through the nodes in the middle. So they will not do the optical to electronic transfer, do the retiming, reshaping, regenerating, or go to the cross connect. They can avoid that because more processing means more delay. So we use optical layer, multiplexer, demultiplexer. This service can go from the station directly to the OCC. So just one hop to the cloud. The latency is controlled and very limited. So we can experience this better experience with the optic transport network to support bigger bandwidths, a better protection with physical isolation. Certainly that we are going to launch this 5G-oriented and powerful solution for the future railway mobile communication. As we all know that GSMA is coming to the end of the life cycle. So USA and many railway operators in Europe, in China, they are doing some pilot, they are trying this FRMCS technology in their test lines and trying to figure out what's best for their own country. So as GSMA, the bandwidth is limited and there are many components involved, difficult to introduce new services, and also the ecosystem cannot support GSMA anymore in a longer run. So the FRMCS is around the corner, and Huawei is very active to participate in the USA to join the standard writing process. So you can see now that we have this FRMCS technology, which can be 4G and 5G compatible. Because the LTE, we consider it's a very mature technology, widely deployed, and it will coexist for a long time with 5G. And also Huawei, as Mr. Yu just mentioned in the speech, that we have this experience with the freight line in China using the LT technology to do the multiple locomotive synchronization use LTE. It has been successfully in operation for 7 years. And also the ecosystem, the cable radio, the dispatcher, the component terminal is quite mature. So in some countries, if the spectrum or the end user, they prefer use the 5G FRMS, we can do it with the LTE technology. And all the hardware for the base station and core network is ready for the 5G. So it can smoothly evolve into 5G by some software upgrade. It will save your invest. So that's the reason that we are here today, that to witness this, that we are going to officially launch this FRMCS. And also you can say we have this white paper, printed copy. You can get it there at our entrance. And also, you know that we have this barcode. You can download the electronic version of this white paper of FRMCS, which shows the industrial trend and the network structure, the 4G, 5G compatible structure, and what service the FRMCS will bring us, not only the signaling, but also many like intrusion alarms, trackside IoT, CCTV camera, all the IoT sensor equipped with on board. So that we can have this technology within writing in white paper. So at the end that you can see Huawei has rich experience in the transportation industry. For the mainline railway that we have been widely used worldwide in different countries. Totally there's 130,000 kilometers serving the top 50 like railway operators. Also the urban rail lines, we served more than 300 metro lines in the metropolitan areas. I think the digital transformation for the rail industry is an endless journey. So it requires participation from different parties, like our customers from metro or railway operators to share your concerns and pain points, and also our solution partners to bring your smart services on our platform. And Huawei, we do what we can do best to enable the intelligence, reconstruct the platform, and reshape the connection. That's my speech today. Thank you.
Mr. Zhongxi, such a pleasure to have you here. You disappeared a little bit early from the stage. It was an excellent presentation of Mr. Zhongxi. The applause was more than earned, really more than earned. I really would like to highlight again the launch of the 300G OTN solution, and please feel free to see and talk to our expert downstairs at the booth to explain to you what it actually can deliver to you. We had so many news about our technologies in Mr. Zhongxi's presentation, so please have a look into our booth and see what we can actually deliver into your operation. Now let me go a little bit through logistics. So you all should have this little card in front of you. I hope you still hold on to it. You will find a QR code there. If you scan that QR code, you will go to a questionnaire, and everyone who filled out the questionnaire will get a little gift at the exit at the end of the event. So you still have plenty of time. I just want to remind you, don't discard the card. There is something behind it. So when you got some time, maybe scan the code and go through the questionnaire. So now, our next speaker, I mentioned at the beginning, he will join us through a video link, and this is actually going to be from CARMET. CARMET is the China Association of Metros. The speaker is Mr. Li Songhao, and he's the director of the China Association of Metros, and will explain us and show their views and track record, actually, of how digital transformation of the urban rail transit is actually applied in China. I just want to remind something. I've been in the rail business for quite some time, and CARMET has a track record of specification and guidelines they have put out on how metro operators in China should apply technology into their day-to-day operation. This is something very unique, and for the metro operation system, it's something very unique. And the association has, over the years, demonstrated that this actually delivers great value to metro operators in China, and I do believe also to metro operators all across the world. Some of their specifications are actually available in English as well, so I think have a look what China CARMET is actually offering to you on this item. Okay, so now without further ado, please would be welcome on the video link to Mr. Lee Song Hao, please. Thank you.
Hi, everyone. Thank you for coming. Today, I'd like to talk about the digital transformation of urban rail transit in China. Over the last few decades, urban rail transit experienced rapid development in China. Year 2020 marks as the turning point. It was in this year China shifted its focal point of the urban rail development from the speed to the quality. What's the difference, you may ask? Well, speed-centric development is mostly realized through construction more railways and improving management efficiency, but the quality-centric development relies on the optimal operations. Our goal is to build a network-based, smarter, and eco-friendly urban rail systems. From 2021 to 2025, we will focus on the networks, operations, equipment, enablement, and economy. In the network field, we will coverage urban rails of the different forms, such as the high-speed railway, intercity railway, intracity fast rail, metro, monorails, and light rail. In the operations field, we will strive to enhance the security and the resilience of the urban rail system. Here, the resilience means the capability of the withstand against the natural disaster and the major incidents. When building its proprietary urban rail systems, China is going down the road of the eco-friendly and smart development, and issued a number of the official guidelines to coordinate implementation. First, let's have a look at the smart development. The smart urban rails development online, one of the key guidelines that China issued, takes effect on the March 12, 2020. This document provides the guidance for the smart urban rail development across the country. The key object of the building smart urban rails is help to keep the country maintaining faster economic growth. To achieve this goal, China released the 1811 program. The first one figure starts for the blueprint of the smart urban rails development. The second figure starts for the 8 service systems covering smart passenger services, transportation organizations, green energies, train operations, technology equipment, infrastructure, operation and management, and security, and network lines management. The third figure refers to the centralized urban rail cloud and the big data platform, and the last figure means the unified technique standard system. Now we move to eco-friendly development to minimize the impact that urban rail development may bring to the environment problems. China launched 6 initiatives to cover every phase of the urban rail's life cycle and every link of the industry chain. First, a comprehensive plan is drafted to coordinate detailed implementation of the environmental protection policies. Second, advanced technology are used to improve energy efficiency and reduce carbon emission. 3, actively promotes the usage of public transport to minimize the total energy consumption. 4, the clean energy replacement program is implemented in order to gradually ease our reliance of the fossil fuel. 5, producers are manufacturing more eco-friendly equipment during the entire productive process. 6, all improved parties are carried out eco-friendly transformation to the reformed urban rail development. Here are some data of China's urban rail development. From 2021 to 2025, China will build about 5,000 kilometers of new urban rails during the 5 years. By the end of 2021, China had built a total of 8,448 kilometers of the urban rails, and the annual investment in the urban rails development had exceeded 500 billion yuan. The urban rails cloud is the best of the smart urban rails development. Based on the 1811 blueprint, the cloud will cover all business domains and all forms of urban rails. China is reformed to traditional single building system into the unified multifunctional platform. The new platform will cover the entire transportation business, rail constructions, operations, management, security, protection, and passenger services. Even the enterprises that run urban rails will benefit from the new platform in the business management, enterprise management, and the construction management, the asset management. Additionally, the platform were integrated with the urban rails in different forms, such as the light rail, monorail, train cars, both rubber wheels and rear wheels, fast rail and neglier. In the future, we will be able to connect to the platform to other transportation systems such as the road traffic, the aviation, the logistic express delivery, urban shared bike, and the bus station to enable linked in smart transport. To build such an all-round platform, China must adhere to the 3 steps plan, that is from independent transport to the linked transport, then to smart transport. Industrial standards will be needed to guide capability, adaptation during the development in the independent transport phase. China released a series of LT4M standards, which I'd like to elaborate later. In the linked transport phase, China released a series of specifications, especially those of the urban rail cloud. In the foreseeable future, more standards will be available for the smart operations, big data, and the PaaS, and the first draft of the big data platform standards is already released for the public review. Next, let's talk about LTE for metro, the communications technology that China's urban rail system uses in train control. LT4M plays a critical role in the urban rail operations. In the past, China lacked dedicated Wi-Fi channels for the transload communication. The lack of the frequent data transmission interruptions seriously affect the safe operations of the fast-moving trains. To address this issue, China approved the 1.8G frequency as the dedicated channel for the urban rail communications. Even since then, we began to work with leading communication technology vendors such as Huawei to develop our technical capabilities. LT4M was extensively implemented in China because of its optimal technical features. It perfectly meets the wireless communication requirements in the urban rail transit scenarios, and the data transmission's performance is reliable even for the train speed over 200 kilometers per hour. The China Association of Metro released the LTE standards to guide the nationwide urban rail development. Our standards include the general interface, technical, test design, and engineering. Together with more than 20 enterprise partners and customers, we built a robust industry chain and a safe, reliable, and stable beer signaling system. Comprehensive standards and metro technology promote the implementation of LT4M. Up to date, this technology has been extensively applied in the train signaling system of over 150 lines in the more than 40 cities in China. LT4M in turn has promoted the evolution of this signaling system and the service as the foundations of the ICBTC, FAO, and VBTC to sum up the applications of LTM breakthrough security and efficiency. Bottlenecks of the traditional signaling system, this new technology enables bidirectional closed-loop train-to-ground communication, stressfully operational security. In addition, LT4M supports the refined control of the location and speed of trains, improving urban rail transit efficiency. Now, let's move to the urban rail cloud platform. In the past, each of the 8 major systems had its own private network and infrastructure. Constructing another lines at a different time means there will be different network. This made us realize that we needed a digital platform for the network construction and operations in the future. We then proposed the construct and the Urban Rail Cloud platform to support the information-driven construction of urban rail transit. The platform can be support transportation operations, enterprises manager and passenger service. It can manage network computing and store resources in the unified manner. The cloud platform improves IT resources usage by 50%, save more than 100 square meters of the equipment room at each station, and greatly boosted service securities. Promote the digital transformation of urban rails. We have planned a series of specifications. We first introduce general information system specifications to the urban rail transit domain. Then, we formulated technical specifications which covered the three aspects: general requirement, the technical architecture, and the network security. We also proposed the technical specification of 5 aspects. The shown in the figures. In this April, we released the design specification for the informatization and engineering of the urban rail transit. This document lays our foundations for the construction of the information systems of new train line. We have also released a draft big data platform specification for the public review. This one is proposed because the big data platform of the urban rail transit is essentially a shared data platform. It is a typical service-driven application of the information and operations technology equipped with a real-time control system. The first urban rail cloud platform was built in Huawei. Huawei is among the first to participate in the operations of urban rail standard and promote the industry showcase project. Huawei cooperates with 30 industry partners to propose a series of approaches to strengthen the digital foundation of the cloud platform. We are looking forward to the global popularity of the one-stop solution in the future. Please note that is the solution of the construction of digital foundation, not to manage all business. This table shows the progress of the urban rail cloud implementations in China cities. With the green marker have started constructions. Cities with the yellow marker has start planning. Relevant tasks are also proceeding in the rest one with the white markers. Our latest planning is to visit the cities with white market and promote the progress of the urban rail cloud construction there. We want to make sure the architecture of the urban rail cloud is placed when new lanes lines are constructed in the 45 cities in China. This figure displays in the framework of smart urban rail construction based on the urban rail cloud. As we mentioned previously, there is a cloud supporting all 8 services: passenger services, transportation management, green energy, train operations, network-based rail transit management, operation and manual security management, infrastructure and technical equipment, the specification released and the overall framework together form foundations to promote the construction of the urban rail cloud. Here is a typical applications of the urban rail cloud in Shenzhen Metro, supported by Huawei. Digital transformation is never a technical issue, but an issue of productive relations. The key is construction and overall architecture of urban rail cloud. Here, gaps are identified and the top-level design is thereby formulated. The design and blueprint guide the talent cultivations and support the strategic transformations, pilot and deployed to lead iterative development is very important. Iterative development. Key highlights of the Shenzhen Metro project include the smart station, intelligent O&M, and intelligent passenger service. A unified technology platform is built to support information driver service in the future. Urban rail transit in China has leaped over the past few years. Various industries and cities have made the great effort to achieve that, and the prospect is promising. We are looking forward to sharing our experience with the global peers and building ideas of urban rail transit together. Last but not least, I wanted to call upon our transport practitioners to promote smart and eco-friendly urban rail development step by step through cashless innovations and practices. Thank you.
And again, a very impressive presentation demonstrating all of the activities happening on the urban metro market in China. I just want to remind the map which was shown, the table which was shown of all of the constructions going on urban metro lines, and the important role CARMET takes to ensure that these lines are built on a template, on a standard. So actually it will be more efficient and easier for these metro operators to just follow the guidelines and to build their system block by block. That makes it much more efficient than to start from scratch for every and each line. So CARMET has been doing these for so many years, and really I applaud their efforts and activities because it definitely makes a big change and help in the metro market, in the transport market. Now, even with moving further, not looking only into the metro line itself, but as was mentioned during the presentation, also looking into other operator mode like bike sharing or ride sharing opportunities. So the end-to-end journey of the traveler will be a mobility as a service opportunity. Okay, the next speaker now will be, I need to look into my paper again with the name, Mr. Sanyuvid Apushatapul. I hope this was correct. Mr. Sanyuvid, you are Superintending Engineer of the Signaling and Telecommunications Department of the Thailand State Railways. I welcome you on stage.
It's okay for the sound checking? It's okay? Okay, thank you very much. Okay, good afternoon, ladies and gentlemen. May I say first, I'm quite excited now because as I know I'm the last speaker. Anyway, for the working in the world of signaling, we cannot excited when we stay on site, right? But on stage we can excited. Anyway, for the signaling, it's quite important for the railway. Normally we think the railway, the most important is the track or the rolling stock. But signaling is really important for the keep the time or the safety issue, right? Today, I would like to introduce about new ICT to support CTC and future evolution of SRT. May I introduce myself? I'm Sanyavit Apichatapong. I'm graduate bachelor degree in electrical engineer from King Mongkut Institute of Technology, Lakabang in 1995, and then I graduate master degree of business administrator from Ramkhamhaeng University in 2002. For my responsibility, since I started SRT around 24 years ago, I took care for railway signaling, especially for the double track project. Since 2002, we call the double track phase 1, we call ST1, until now we finished the ST6. And now ongoing for next step for ST7, 8, 9, 10. Ongoing. And current situation, I'm the supervising on maintenance of signaling and telecommunication in the central area, especially for the Red Line project and the CTC system. Just briefly about the state level of Thailand area. For coverage area, we start from Bangkok station, we call Ho Lampong station, to the northern until the Chiang Mai station. For northeast line, we connect to the Laos at Nong Khai station. As maybe somebody didn't know, we can cross from the Thailand to Laos at the Thanalang first Laos station. And also at the eastern line, we can connect to the Cambodia at Arunachal. I think maybe not so long time we can open to operate between country. And at the southern, we connect to the Malaysia at the Sungai Golok station. Totally length of railway approximately around 4,070 kilometers. And in the detail for the network and the system, I will explain after this. Next is about the signaling system in SRT. As you can see, we have the several systems nowadays in SRT since the mechanical interlocking. I think someone can just see this one from museum only, but in Thailand still can use. But it's also safety. We call the mechanical interlocking control by the level frame to control the semaphore signal. And then next generation, we have the electrical system we call all relay interlocking, controlled by the local control panel. Use the push button to control the relay, go to the color light signal, which the electrical point machine. After that, we have the concept of the computer-based interlocking by the VDU to control the microcontroller to control the signal. As I heard in the Chinese name, Jishun Ji Lengshua, right? Jishun Ji Lengshua for the computer-based interlocking. Okay. Next is for the train management or the traffic. We have the traffic control system we call the train dispatcher. As you can see, we use the manual operation almost coverage area in Thailand, and we still have the draw train graph by hand, by manual draw, right? Anyway, SRT also modernized the train dispatcher control by the computer to cooperate and make the system like the train graph or the automatic loop setting. We call the centralized traffic control or the CTC system. Now we have the CTC system to control in the central area at the area in the Bangkok we call the Bang Su building. For coverage area for CTC in Bangkok, we control and monitor from Bangkok until the northern station at the Lopburi station. For southern to the Nakhon Pathom station, eastern to the Lam Chabang station, and northeast to Makabao station on the way to Nakhon Ratchasima. As I explained, I can briefly explain before next stage. For this coverage area is coverage for the double track project in Thailand. So about the function, we can see here at the CTC center, you can see the station. Since, for example, it's the Bang Khen station in Bangkok station until the Ban Po station. Ban Po station is nearby the Ayutthaya station. But maybe you suggest that why not too many stations? This is just the one zone. We divide by zone. For one zone, allow the 8 or 9 stations, and we can choose the zone from here. We can see this zone, zone number 1, number 2, number 3 in each the operator. As you remember, I explained about the train graph by the manual, right? But in this time, when we use the CTC system, we can draw the train graph by the computer, and we just insert the timetable inside, and it can generate automatically and can record everything inside this. So let me go to the CTC system architecture. I think the almost CTC in the world, similar to configuration like this, we have the main CTC computer, we call the processor server, connect to the workstation operator control. In SRT, we call the line station with the MMI, man-machine interface, to monitor and administer everything, and also connect to the timetable to create the train graph. For this group is located at the CCC center, include the communication network. Communication network will communicate to the field station, that means the interlocking station in the wayside, in the coverage area for the central that I told before. So today I will focus for the communication network. It's quite important, and the core network for communication between the CCC and the system. Let's see this communication network support to CTC. As I told before, we have the communication to coverage in the double track area. In SRT now, we use the SDH network system architecture for the double track that I told before. We call the ST1, ST2, ST3, ST4, and ST5 to connect to the central CTC at the Bangkok. We separate by the color also. I'm excited. At the ST1, for the yellow color, we connect the SDH system. It's different the vendor, yellow, blue, and the green color. And the latest is the ST, we call the ST5 from Chachoengsao to Gangkhoi in the purple color. This is the first SDH installed by Huawei. Okay, this Huawei system we can monitor and set configuration on this monitor, and this system still can work properly around 3 or 4 years. Next is I would like to explain more detail for the SRT network and nowadays and in the future what we're gonna go. Nowadays we have the route length around 4,000 kilometers that I told before, but in detail we can say that we have the single track around 3,600, maybe around 90%, and double track, including triple track, less than 10%, which is very few. You can imagine, as I said, that I work for double track project around 20 years. Why 20 years? Just the 10%. How to be the 100%? Can you calculate how many years? Maybe another 60 years, 70 years. Okay, if I can have the age enough, I can do my work. But how we finish? Let you see the next page. Okay. Luckily, because before why we go slowly, because each project we go project by project, but the policy of the government, Thai government, they plan to do it at the same time as possible, because we want to develop our country to have the coverage area for double track in Thailand, because we know that make many advantage in Thailand, right? So we have the double track project from Gangkhoi Khon 19 and Jira Khon Kaen. These two projects, number 1 and number 2, we done already, right? And we opened around 2 years. And now number 3, Prachuap Khiri Khan Chumpon, มากระเบาจิระนครปฐมหัวหินลพบุรีปากน้ำโพหัวหินประจวบคีรีขันธ์ is ongoing. It's all we call the double track phase ST7, ST8, ST9 that I told you. Now these three projects we run at the same time, right? That means that if the double track phase 1 finish, we can have the more double track around 1,000, more than 1,400 kilometers. And also we have the project for the new route from Den Chai, Chiang Khong, and the Ban Pai, Nakhon Pathom is already bidding already, and we will start the project immediately. Just a moment. Okay. After that, not just this one, we still have the double track project phase 2. Phase 2 from Jila, อุบลราชธานี สุราษฎร์ หาดใหญ่ เด่นชัย เชียงใหม่ Okay, sorry, I forgot. I had to recall my memory. And then after that, we can finish another phase 2. So you can imagine what happened. This just estimate around the 2024. We can have the double track around the 30%. Before we have the just 10%, but after we finish double track phase 7, 8, 9, we can have the double track around the 30%. And then if double track phase 2 and the new line finish, we forecast around the 2027. At that time, we can have double track around 70%. 70% means the coverage area in Thailand, because you can see the blue color. It's just we call like the spur line. It's like the not main line. We remain the single track. But the four main line, that means the 2027. We hope that we can run the double track since Chiang Mai until Sungai Kolok and until Chiang Rai until Ubon Ratchathani. We hope that. Okay. But how about CTC system? Before I said that we have the CTC system at Bangkok to coverage area in central area. But if the double track coverage in Thailand, firstly, we can say that the space not enough in Bangkok. It's the one limited for the location to install. Second one, that I explained, every project is not started at the same time. So how can we make the one CTC in this time or the near future? So we have to wait until all coverage area finish. So we have to go ahead to make the CTC in local. So for each project, that I said before, we have the CTC at the Bangkok area to control in the central area, and then ST7, ST8, and ST9 for red color. We ongoing for the CTC process for the Nakhon Sawan building, Hua Hin building. That means in nearly future we can have another 2 CTC. Before that, we have the second CTC already at the Khon Kaen station to control the station, interlocking station since the Jila until Khon Kaen, and we provide space for the future until the Nong Khai station. So, if we have the many CTC, what do you think? In SRT, we consider about this one really deeply. Is CTC separately possible or not? Or we want to centralize? We research in many countries. Some countries, after finish all, demolish all and make the one CTC. Some countries remain the local CTC like this. So we have many solutions to consider. Anyway, we consider one solution. Just on researching about the solution to centralize CTC in one CTC in Bangkok. This idea, I will explain the idea. First, in the bottom, this is the architecture for each CTC that I explained before, and maybe we grouping in the below. That means for the area. For example, northern area, northeast area, southern area, something like that, right? And then after the below communication, we connect to the main CTC at the backbone, at the center, right? We call the backbone network, CRSC architecture for whole network. We combine all in Bangkok. This is one way we're thinking. Why we consider about this solution? Because we still have the local CDC. And we can control here, and we can monitor here, or we can have the below. It depends. But maybe we can modify this one. Why we have the below? Maybe from Huawei, you can understand in this model, we apply from the China Railway, because China, as I know, China Railway, we had the below, because China is a big country, allow 14 below, right? 14 below, later they had the area, and then we connect to the one system. But in Thai, maybe we can connect from the CDC to the backbone network directly, or below, it depends, because we have to consider after every CDC finish, okay? What happened? As I explained all about the CDC system to try to centralize. If we use this architecture, not just the CDC benefit, the benefit will become after we had the backbone network. As we know, the technology really increasing. Not just the CDC, we can have the more benefits such as number one, multi-service access. That means not just the CDC, we can have more application. Easy to explain like the CCTV, PCM, SDH, or SCADA. We can use in our backbone when we have the centralized CDC. Number two, large bandwidth. After we can use for many applications, but we can have a very big bandwidth and we can provide for the future if we have the more line or the more application. Number three, low latency. Low latency, that means we can have the concept of the hard pipe. Hard pipe, like after we connect to many CDC, we can have many data and transmit to many traffic, we can say like that. And we can divide by pipe. Really simple to explain. Really hard pipe, and we can set up for the priority, which one is the vital and non-vital, high priority or low priority by the low latency concept. Number four, high reliability. Because of connection to the big network like this, we can have the high reliability, various protection, warranty, and let's say really simple, like the very low failure. Number four, synchronization. Because we use in the same network, everything we can synchronize because we can use the central network, below network, and CDC local, we connect by the same system. That means everything can synchronize such a clock or the data transmission. Okay. The last for the smart OAM, because the same network, we can easy to do for operation, administrator, and maintenance. That means this advantage will be happen after we have the centralized CDC in the future after we run the project for the track. Okay. So as I explained for this architecture, I hope to see next picture in Thailand in the future like this. Maybe you can know this is Beijing CDC. It's really famous in the world. We can see everything, right? We hope to see that. I'm not sure in the next future which technology can support this one. Maybe from Huawei. Okay. Okay. Thank you very much.
Sorry, just wanted to say thank you for your presentation. It was a pleasure, and it's very exciting to see all your signaling projects going on. So thank you very much. Thank you. So we are moving towards the end of our workshop today. We have another presentation coming, so I'm running out of desk space here. So after the presentation from SRT, we are now moving towards, and it's another presentation about signaling. So I'm very excited to actually welcome on stage Mr. Sang Chiao Lee. He's the Deputy General Manager for the Asia Pacific Regional Center of CRSC, who will introduce us to CRSC's activities on the signaling side. Mr. Lee, just join us.
Good afternoon, ladies and gentlemen. Today it's my great honor to be here to share our company's information and some activities by CRSC. I come from CRSC. Today my speech consists of 4 parts. Part 1, company profile. China Railway Signal and Communication Corporation Limited, known as CRSC, is a large central enterprise directly managed by SASAC. We call it the State-Owned Asset Supervision and Administration Commission. We are a high-tech industry group featuring the rail transportation controls technology and the world's largest provider of rail transportation control systems. We boast a complete industry chain from design and research and development to manufacture and engineering services for rail transportation control systems. And we serve as China's competent management authority of equipment modes, technical standards, and product standards of control systems for rail transportation. We were listed both in Shanghai and Hong Kong stock exchange market. CRSC is a core enterprise for safe operation of China's rail transportation. We are a representative of its own national industry of train control system technologies for high-speed railway. And we are a leader of its core technologies for high-speed railway, leading the global railway industry. By the end of 2019, our world-leading train control systems technologies have provided a safety guarantee for 139,000 kilometers of railways, including 35,000 kilometers of high-speed railway. In recent years, CRSC has developed automatic train operation technologies for high-speed railway at speed of 200 kilometers per hour and 350 kilometers per hour. Here you may see the development of China's railway speed up and upgrading, and the development of CRSC in the past 7 decades. And to meeting the requirements of speed up and upgrading of China's railway system, CRSC has contributed in signaling and communication technologies. We could say that CRSC grows up together with China's railway. Here is our organization. Left side, it shows the organization of our headquarters. On the right side, you may see the members of CRSC. There are 13 Tier 2 companies and subsidiaries wholly owned by CRSC. And you see here, CRSC International is one of them. And we are the only one for the overseas business and management. And we also have another 3 companies controlled by CRSC. Casco Singular is one of them. We have 7 major business segments, including signaling and communication, information management, information engineering, power supply and electrification, and emerging businesses, and overseas businesses, and EPC contracting, and capital operation. We are capable to provide one-stop services with our own 8 core technologies. We left our footprint in the global market. for the purpose of our for the purpose of our management and overseas businesses, we allocate 5 regional centers. Yeah. The Asia Pacific Center located in Bangkok, Thailand. And under these 5 regional centers, there are many product sales organizations and projects in many countries and districts. In the upper right, you may see the market share for CRSC. We are the biggest provider for our train control systems. From the histogram, you may see that for both VSAT equipment and CTCS3, which is equivalent to ETCS2, our shareholder more than 90%. Part 2, our solutions. As you may know, the rail transport systems consist of several sections, as shown here, and CRSC's business have involved in all sections above. And here I marked 4 subsystems, such as communication system, centralized monitoring system. There is a business and technology cooperation between CRSC and Huawei in rail transport. And next, I would like to give you the brief introduction for our system solutions, the same with our 8 core technologies. Number 1, China's train control system for high-speed railway. We call it the CTCS3, which is advanced, safe, and autonomous and controllable. Number 2, China's automatic train operation system for high-speed railway, CTCS3 plus ATO. Number 3, the train control system for urban railways. For urban transit, as we know that the CBTC system is widely used for metro, light rail, and monorail. CRSC has possessed the 2 types of CBTC system. And number 4 is a train control system for ICR. We call it the CTCS2 plus the ATO, which is the first high-speed railway, which is a excuse me. Number 5, the train control system for medium and low-speed maglev. And number 6 is automation system, CIPS, for freight marshalling yard. And number 7 is a railway integrated intelligent operation maintenance management system for high-speed railway. Number 8, integrated transportation dispatching and commanding system. Here, regarding to the China's train control system for high-speed railway, both the CTCS3 and the CTCS2, I would like to talk about more at. CTCS3 system, which is equivalent to ETCS2 system, and it's developed for the high-speed railway with a speed of 350 kilometers per hour, and the train headway is 3 minutes. Our total operation length is over 20,000 kilometers. Well, CTCS2 system, which is equivalent to ETCS1 system, is for the high-speed railway with the operation speed around 250 kilometers per hour. The train headway 5 minutes, and the total operation length over 13,000 kilometers. And part 3, industrial trains of rail transport. as you may know, with the development of economical globalization, the development of rail transit promotes cross-regional development and pursues faster, more sustainable, safer, and more economical. All of these are very much in demand for the development of signaling and communication technologies. Here I collect the information from 4 features. The higher speed for passenger transport, the speed raised up from the normal speed to super high speed, and the heavier for the capacity weight of the rail transport. It's boosted from 8,000 tons to 100,000 tons. And you see, the higher speed, the denser for the train operation, and the higher requirements and demands for the train control system. So it's for the train control system, it's developed from ETCS 0 to ETCS 3, which equivalent to CTCS 1 to CTCS 4. Accordingly, and now we are at the stage of CTCS 3 and ETCS 2. And lastly, the rail transport developed from the single lanes to cross-lands, cross-region, and cross-border to be connected and intermodal. And there is interoperability requirements for railway operation network among the cross-lands, cross-region, and cross-borders. However, in different countries has different technology standards. So it is obstacles and barriers for the development of the rail transport to connect the neighbor countries, to connect the cross borders. As you may see, European countries, they have their own technical standards as ETCS system. And in China, we have our own CTCS technical standards. So we are view that the efficient way to solve these difficulties and obstacles is to establish the technical standards suitable for the regional railway network development. And meanwhile, the digitalization can meet the requirements for railway upgrade, reconstructions, and interoperability, such as the digital-based interlocking technologies, etc. And we notice that in recent years, more and more countries paid high attention to develop the railway networks to connect it closely with their neighbor countries and develop the social and the economic, especially for the Asia-Pacific countries. And finally, we can see that all the countries connected are the final beneficiaries from this development. We can imagine that in the short future, the China's railway network linked with Southeast Asian countries means that the Trans-Asian Railway is further built. We think that it's necessary to work together to establish the regional technical standards suitable for the ASEAN railways to promote more efficient regional railway development, which will bring with the social and the economic development. All of us know that the technology development of train control system and for railway and urban railways, together with communication development, In past, CRSC and Huawei, as the experts of our own fields, made a lot of efforts for the technology and corporations, such as the CTCS carrying on the LTE-R network and the CBTC based on the LTE-M multi-service barriers communication technologies, which were proven that it was successful and sustainable. For the development of direction of the intelligent high-speed railway includes the intelligent construction, intelligent control, intelligent operation and maintenance, and intelligent services. All of these are based on the development of technologies for the signal and communications. For part 4, I would like to share our achievements and some project experiences. Our working references covers the following items shown here. We are capable and willing to provide the one-stop service for our dear customers. Here, CRSC established a laboratory and test center in Europe. It's equipped by ETCS2 standards equipment, and all the equipment and systems provided and produced by CRSC. And the laboratory focus on displaying CRSC's autonomous equipment and the carries out of follow-up the product maintenance and user-oriented training and teaching activities. And another laboratory and test center is under establishment in Bangkok, Thailand for Asian Pacific. The train control system complies with ETCS1 and CTCS2 technical standards. We noticed that both in Thailand and Malaysia, ETCS1 and CTCS2, even in future, the CTCS3 equipment and technical standard will be adopted. So, between CRSC and Huawei, there are many cooperations, in past and future, in and outside China, such as the high-speed railway between Shanghai and Beijing, China-Laos Railways project in Laos, and China-Thailand high-speed railway projects in Thailand, and East Coast Railway project in Malaysia, Jakarta-Bandung high-speed railway in Indonesia, Hungary-Serbia railway, and double track in Thailand. So Huawei works as a partner for communication and providing products and technologies. As we know, the RCEP coming to force in this January, so the regional industrial cooperation will be further strengthened. The connectivity in the Asia-Pacific region will increase the demand for transportation, especially for the rail transportation networks. So, to set up the technical standards which are suitable for the regional development have realistic significance. Let us work together to deliver faster, safer, more sustainable, and more cost-effective rail transit systems that serve regional connectivities and economic development. We are your trustworthy, reliable, and sustainable partners. Okay, that's all. Thank you.
Thank you, Mr. Sang Choli. It was such a pleasure to have you here on stage, and what we can see, CRSC is really, truly signaling supplier, globally signaling supplier. I asked you to stay on stage because we will do a photo all together. So, but we also need the other speakers we have had today. Would you please join us on stage so we can take a little bit of a photo? Please. Mr. Sanyawit Apashituk, Mr. Shang-Chi, and then we got Mr. Aaron Wang. Would you join us on stage, please? So we just go a little bit more to the middle. Yeah, sure. Okay. Thank you again. Okay. Oh, but we're still. Thank you. Thank you very much. So there's still a little bit of admin I have to go through with you. I mentioned earlier today this agenda you got on your table, and I'm sure all of you already started the questionnaire. When you scan that QR code on that card, you go through the questionnaire, take a snapshot at the end of the questionnaire, because then when you go out in front of the room, you can actually get a nice present. And there it is. I'm talking about the box. The box. So we're talking about the box. Just the box, nothing else. But everyone gets a box, and when you just have to go through the QR code. But there's something else you can get outside. And don't get too excited, but you also get some refreshments outside. So it's just outside the door. I thank you so much for joining us. I hope it has been interesting. You learned something new. You got some new ideas. If so, please contact your Huawei person. And we are more than happy to show you more about all of that stuff. And of course, we are downstairs in the exhibition area where we got all the technical experts for you. Thank you so much. And I wish you a fantastic time here in Bangkok, and enjoy the rest of the event. Bye-bye.